An electric circuit is a closed-path interconnection of electrical components that charges move around. Consider a simple electric circuit with a light bulb and a battery. The battery creates an electric force that causes the charges to move around the loop. This flow of electric charges is what we call electric current, but positive charge or negative charge. In reality, the electrons or negative charges can move in the conductors. The positive charges stick to the nucleus of the atoms and have no mobility. However, the electric circuits existed long before the discovery of elementary particles. At that time, it was falsely assumed that positive charges move in the opposite direction. Therefore, by convention, the direction of current is based on the direction of flow of positive charges. However, we know that the negative charges move in the circuit at the opposite direction. Mathematically, electric current is the time rate of change of charges. Basically, the current at a specific point in a circuit is the number of positive charges passing that point in 1 second. When the current is doubled, the number of charges passing that specific point is doubled. And it is absolutely necessary to show the direction of the current. If you say the current is 2 amp, you also have to show the direction of the current in the circuit with an arrow. When charges move in an electric circuit, the energy is transferred from one point to another. The difference in electric potential energy level between 2 points is what we refer to as voltage. To measure the voltage between 2 points, we compare the energy level of a unit of charge at these 2 points. Therefore, mathematically, the voltage is energy needed to move a unit of charge between 2 points. This electric potential energy is similar to gravitational potential energy. Think about an apple falling from a tree. When you release the apple, the force of gravity pulls it down. We say the potential of point A is more than point B. When the apple is released, potential energy is converted into kinetic energy and moves the apple from point A to point B. But for moving the apple from point B to A, you need energy to move it from lower potential energy to higher potential energy. The same thing happens in the circuit. Charges may gain or lose energy when moving from one point to another. In a circuit, when the positive charges flow from higher potential to lower potential level, they lose energy. And when they move from lower to higher potential level, they gain energy. In this circuit, in the light bulb, when the charges move from higher to lower potential, they lose energy. This energy is converted to other types of energy like thermal and light. Therefore, the light bulb is consuming energy. In the battery side, the charges move from negative to positive terminal, which is from lower to higher potential level, and they gain energy. This energy is the chemical energy stored inside the battery, which converts into electric potential energy. Therefore, the battery is generating or supplying energy to the circuit. Note that voltage is always measured in a relative form as the voltage difference between 2 points. The notation used for higher and lower potential point is positive and negative sign. The devices such as batteries that supply energy to the circuit, referred to as active elements. Components that consume energy, like light bulbs, are called passive elements. Based on the law of conservation of energy, the energy supplied in a circuit is equal to the consumed energy in that circuit. Since power is the time rate of energy, we can extend that to consume and supplied power in a circuit and say sum of the consumed power in a circuit equals sum of the supplied power.